Let's examine code example 5.9 from the book Computational Thinking and Social Science. The example shows how to calculate the degree of each node on the network file. So instead of focusing only on one node, we focus on many nodes. And to do this, we need to not use only variables, but instead use a dictionary. So the dictionary decrease is here to sort of store the value of decrease of each of the node. So A, B, C, D, E, F, and G corresponds to nodes on this network. And why we do it in this way is that we want to make some stuff easier for us. So usually you could of course have several variables like degree A, degree B, and all of those start from 0, and then you would check with an if sentence that if the node happens to be the same as A, then we increase degree A by 1, and if it's B, then we decrease B by 1. There's a difficulty with all of this, which is that it gets really difficult and really verbose to create something like that. So instead of doing that, we will use a dictionary that makes some stuff easier for us to manage. So we initialize their 7 nodes, and all of them start with value 0. We have here the edgelist file. And the edgelist files, so that we remember, it has stuff like this. So this would be that A is connected to B, this would be A is connected to C. What we do is that we first separate the 2 nodes, so A and B, or A and C, from the file, using these lines here and this line here. So we say that node 1 is the first bit of this and node 2 is the second bit of this. And then to properly calculate this, we need a gatherer kind of thinking here. But instead of having one gatherer variable, the gatherer actually is the decrease thing. So this is the meta gatherer from the book chapter. So we need to get the previous value of the gatherer, then we increase it by 1, and then we update that into the structure. So if this is the decrease dictionary, it looks something like this. It has keys A, B, C, D, and so on. And then these keys have corresponding values. So this is 1, this is 1, this is 1, this is 1. At this, when we execute this, these are all 1s. Then we start working on here. And if we start with AB, so now node 1 is A. We ask it to give us the current or previous value by looking at node 1 from the decrease. Well, that is 0. Then we add that by 1 and store it back into the decrease at key node 1. So we, because node 1 was A, we say that this is no longer 0, this is now 0 plus 1, so that's 1. Same when we have B, we move and we sort of say that yes, let's take the previous value at the decrease dictionary at the key B, and then let's add 1 to it and put that back into the dictionary at value where the key is B. So again, also for this, we instead of saying that there was 0, we say that there was 0 plus 1, so that was 1. Then we've gone through that pair, we can move into the next pair, AC. So here, node 1 is again A. We ask that what's the previous value in the decreased dictionary at key A? Well, that's 1. Then we say that let's store back there the previous value plus 1. So instead of being 1, again update this to say that it's now 2. And so on, we would follow up with all of the files and all the lines in the file. And then we would just print them out here. So we would print the name and decree value. So the actual trick here, the really critical trick, is that instead of saying A and B here, we use those variable names that indicated that we want a certain key from the dictionary, not a certain variable. That's the trick with metagatherers.